Okay guys, this is our last question for the show. This is the Tenfold Live Show, so if you just joined us, it's the Tenfold Live Show, proudly sponsored by Liberty. Guys, we're busy doing our last question on analytical geometry before we go over to next week where we start looking at exam preparation. We got a question today from 3 learners, Kimberly, V2 and Michelle. Let's have a look at what their question is.
Go. Hi Tenfold, my name is Vitumbiko Chumia.
And I'm Michelle. And I'm Kimberly.
We're from Cape Town and we really need assistance with this maths work because tomorrow we're writing maths.
Okay, so that's the question from V2, Kimberly and Michelle. Let's have a look at what it has to say exactly. So it says that in the figure, the origin O, P, R and T are vertices of a square. So that might come in handy when we start looking at properties. And it says that E is the point 1 and 2, and that's the point of intersection of its diagonals. Okay guys, so if we have a look at this question over here, we get given a square. Now in analytical geometry, it is quite useful to use properties of our quadrilaterals. And one of the properties that is going to come in very handy is that the diagonals of a square, they bisect each other perpendicularly. So we're going to use some of those properties to help us in trying to find the answers to these questions. The very first question which we're being asked is going to be write down the gradients of OR and PT. Okay, so if we have a look at our diagram over here, we have that OR is this diagonal and PT is my other diagonal. And I've just mentioned that OR and PT they lay perpendicular to one another. So let's have a look at the first thing that we're going to do. We're going to find the gradient of OR. Now if we have a look on my diagram, to get OR, I have a point which is 1 and 2 that's given to us, and I have a point O. So now there are ways that we can avoid to use my gradient formula y2 minus y1 divided by x2 minus x1. Because I'm coming from the origin, I can then do a change in my y versus a change in my x to try and find what the gradient of that line is going to be. That's what I'm going to do now. So I'm going to say then, to get to point E, I'm going to go up by 2 and I'm going to go across by 1. So that means the following. In doing so, my gradient of OR is going to be rise, which is 2, divided by 1, and that there simplifies simply to 2. Now I'm not done. This part of here also asks us to solve for PT. Okay guys, so what that means is I've got PT, which is perpendicular to OR. So I can then use that nifty formula, M1 times M2 is equal to -1. Or simply, my one gradient is the negative inverse of my other gradient. So that means the following. I have that M of PT is equal to -1 over M, or my gradient of OR, and that means that my gradient of PT is then going to equal to -1 over 2. Okay, so there's my 2 gradients on my lines that I've just found. Let's have a look at more parts to this question. So the next part of this question asks the following. Show that the equation of EP is x plus 2y minus 5 equals 0. Okay, so let's have a look at my diagram, guys. I've just found my gradient of PT to be equal to -1/2. My gradient of PT is equal to -1/2, and I'm going to use that to try and find the equation of EP. Okay. So EP lies on my my diagonal PT. So what I want to find is then I'm going to use I'm going to use my standard form of my equation, y equals mx plus c. And I know my gradient is -1/2. I found that in my other equation, or my other question. So my new form of my equation is going to become -1/2x plus c. Okay, so I know this line goes to the point 1 and 2. To then find my c value, all I'm going to do is I'm going to substitute in these 2 points, and then afterwards I'm then going to solve for that c, and I'm going to find my equation on my line. So my point that it goes through is 1 and 2. This is my y coordinate, that's my x. So I'm going to say 2 is equal to -1/2 multiplied by 1 is still a -1/2, and then that's going to give me plus c. If I then solve for c, I'm going to end up with 2 plus a half is equal to c. And that there means that c is going to be equal to 5 over 2. Okay, so I've now found my value of c, but remember the question asks, I need to find the equation on my line in that form that was given to me. So I'm going to plug in my value for c, and then afterwards I'm then going to multiply through to try and get that form that they've just asked for. So what I'm going to have is, I'm going to have the following. I'm going to have y is equal to negative a half x plus 5 over 2. And if we go back up, we can see that in my equation I don't have any fractions. So what I'm going to do is I'm then going to multiply through by 2. I'm going to get that 2y is equal to negative x plus 5. And in my equation we can see that it was equated to 0. So if I just equate all of this to 0, I'm going to have that 2y plus x minus 5. That's not minus, that's equals. 2y plus x minus 5 is equal to 0. And I've just found my equation in the form that they were asking for. X plus 2y minus 5. Okay, those two variables are just mixed up. Okay guys, so that's fine. I've just found my equation on my straight line. Let's go have a look at some more parts to this question. So, the other parts of my question is determine the length of EP and leave your answer in surd form. So guys, surd form, what that means is that I've just got some sort of root, a cube root or a square root in my answer. I don't want to simplify that using a calculator. I want to leave it in surd form because that's what the question asks me. Now, we want to try and find the length of, let's have a look over here, the length of EP. So we want to find this distance over here. Okay guys, now if you have a look at our diagram over there, we don't have the coordinate of P. But remember, we're going to use those properties that we discussed earlier with a square. Now, because it's a square, the diagonals, they intersect at 90 degrees. But what's also important is that those diagonals, they bisect one another. So that means that my point E, no matter where I go to a vertex on my square, that distance to either one of those vertices is going to be exactly the same length. So I'm going to use that to try and simplify this calculation here for me. So I'm going to have the following. If I then take it from my origin to my point of E, that is also equal to the distance EP. So what I have over here, guys, I'm going to then draw a little 90-degree triangle here for myself to simplify things. And I'm then going to know my distances. I'm then going to have my y distance going upwards is going to be 2 units. I don't want to write with that. I want to write with my other pen. Where is it? There we go. 2 units. And going from this point to my point E is then going to be 1 unit. Okay, guys, so to find the distance, I now have a right angle triangle. I can either use my distance formula or I can use that idea of Pythagoras, which they actually work with one another in finding the distance formula. So I'm going to then say EO, distance EO, is going to be equal to the square root of 2 squared plus 1 squared. I then have, to simplify this, it's then going to be equal to 2 squared, which is going to give me 4 plus 1. And I then have that EO is equal to the square root of 5. Okay, so that is EO. But remember, they didn't ask me for EO, they asked me for EP. But remember, I've just worked out, or I've just told you that the diagonals bisect one another, and at that point to the vertices, all of them are equal. So that means distance EO is equal to my distance EP. So I have then that EP is then equal to root 5. Okay, and that's that question done, guys. So there's a whole bunch of things that come into this analytical geometry. Now, having been the last show of this week, I just want to give us a little bit of summary that we can go for when we look at more analytical geometry. We've got my equation on my straight line, we've got my midpoint formula, and we've got my distance formula. All of those formulas come on my formula sheet, and they're all there to have a look at when we get to the exam. Hey guys, so that's all we have time for this week. We're going to see you next week with exam prep. And you guys have a great weekend, and we'll see you on Monday, 5 to 6. Have a good one, guys.